Hi, this is a supplementary video in the series in which I've been building experiments from this book, Charles Platt's Make Electronics, the third edition. And it's in response to a request from a viewer who was working through the experiments in this chapter, experiment 15, emitting a pulse. And this is the first set of experiments where we get introduced to the 555 timer chip, which of course we use for a lot of experiments from that point on. And towards the end of this chapter, there's a circuit diagram here which shows the wiring for something called reverse mode. Now, this is just a circuit diagram in the book. There is no breadboard layout. And so one viewer sent a message saying they'd had some issues with building this and were disappointed that in my original video for this part of the book that I didn't cover that reverse mode circuit. So I'm going to rectify that now. Apologies that I didn't cover it. I'm going to rectify that now and show you how I've interpreted that circuit and what I've done with it, and I hope that will be helpful for anyone who is trying to use that for an actual build and having any issues with it.
Okay, so let me explain how I've wired up this circuit. So I have my power supply coming into the positive bus on one side, the negative bus on the other. I've just put a couple of jumper wires across so that I can use the buses on both sides of the board just for convenience. So in terms of the 555, let's start with the things that are the same as the circuits you've already seen. So first, of course, we need to supply power to the chip. So we've got pin 8 connected to the positive supply bus. Pin 1 is connected to ground. That's the same as usual. You'll notice that pin 4 down here, the reset pin, is also connected to the positive supply bus, because if you've done the earlier experiments, you'll recall that pin 4, the reset pin, is active low. So for the purposes of this experiment, we want to hold it high. Pin 3, let me just move this out of the way slightly. Pin 3 here is connected to an LED. So pin 3 is the output pin, of course. That's going to drive this LED, and then the negative side of the LED is just connected to ground via a current limiting resistor, exactly as you've seen on other experiments, so nothing unusual there. And you'll notice at the moment that we haven't got an output from pin 3. It's low. Now, where things are a little bit different is that pin 6, which is the threshold pin, is connected directly to pin 2, which is the trigger pin. Now, I know there was some concern about this looks like a little bit of an odd way to wire things up, but don't worry, it is actually perfectly normal, and in fact it is part of the wiring scheme for one of the modes of the 555 that if you've got this far you will have not seen, but it is coming up in a future experiment, so don't worry unduly about that. It is perfectly valid to wire things up in that way. Now, where things probably get a little bit confusing is in the circuit diagram in the book. The author shows pins 2 and 6 being connected to either the positive or the negative supply bus via a double throw switch. The problem with that is if you try to replicate that physically, is that because a switch is not a perfect device, there will be very, very short, but there will be a moment when the switch is travelling from one extent to the other, where in fact neither the positive or the negative supply bus is connected to pins 2 and 6, and they are both left floating. And even though it's for the briefest of moments, I suspect that that is what is causing problems that you're having with this circuit. So having said that, what you might be wondering is, well, if the switch is a bad idea, why has the author shown a switch in that point on the circuit? Well, if you read the accompanying text, what you'll see there is that the author has said he's put the switch in at that point in the circuit to demonstrate that pins 2 and 6 can be connected to either the positive or the negative supply bus. But it is just a conceptual device. It's not intended to be replicated in an actual build. And I suspect that's why the author has not shown a PCB layout, sorry, not a PCB, a breadboard layout for this circuit, because it is just conceptual. Now, what I've done here instead is I've got the potentiometer here, and this is just an ordinary 10k pot. And apologies, this one was wired up for a different circuit, so both of the leads at either end are red, but I've just put a bit of black tape round one to show that that one end of the track is connected to the negative supply bus, one end is connected, the other end rather, is connected to the positive supply bus, and importantly the wiper is connected to pins 2 and 6. So it's going to be the wiper voltage off this pot that is controlling those two pins. Now at the moment the pot is open to its fullest extent, so it's not presenting any resistance at all, and you can see, because I've also got the multimeter connected across this, that we are in fact getting the full supply voltage, a little bit over 9 volts. So as I start to dial up the resistance, what you'll see is that we'll get to a point here where the light comes on, the LED comes on, and correspondingly, if I dial it back the other way, you get to a point where the LED goes off. Now at this point you're probably completely underwhelmed and thinking, well, you know, if you hook up a LED directly to the pot, you're probably going to get a similar behaviour. But here's the important thing. This time I'm going to do the same thing, but what I'm going to do is I'm going to carefully note what the voltage is at the point that the LED turns on and off. So let's start with turning it on. So I'm just dialing it down slowly, and I'm just doing this a bit slowly so I don't go past the point. There we go. So it's about 3.23 volts. Let me just make a note of that. Obviously, if I carry on dialing it down, the LED will stay on. Oops, I've got a little bit of a dodgy connection there, I think, which is why it flickered off briefly there. But now let me dial it back up again and see at what point the LED goes back off. Now you might be expecting it will go off at the same point, like 3.23 volts, yeah? But look, we've gone past that now. So now we're going up to 5, there we go, about 6.13 volts. And then of course if I carry on, it will stay off for the rest of the scale. So here's the interesting thing about this. There is a point on that voltage scale, anything below 3.23 volts, where the LED is always going to be on. Correspondingly, there is a point on that voltage scale, which in our case is anything above 6.13 volts, where the LED is always going to be off. But the bit in the middle of that, from 3.23 to approximately 6.13 volts, the LED is going to maintain its current state. So if it's currently on when it's moving through that portion of the scale, it will stay on. And if it's currently off when it's moving through that portion of the scale, it will stay off. And this is a very useful behaviour for some devices, and indeed the example that the book gives is a very common one, which is that of a thermostat. Now what you don't want in a thermostat is to set a temperature as a threshold and for the thermostat always to switch the heating on when it gets below that temperature and always to turn it off when it gets above that temperature. The reason being that if the temperature is kind of hovering around that point, is your heating is going to be constantly switching on and off, which is no good. It's just going to wear out your boiler. So what you want is to have that kind of no man's land around the cutoff point. So in this case, it will stay on until it gets to an upper bound, and then it will turn off. And correspondingly, if it's already off, it will stay off until it gets to a lower band, and then it will turn on. And that way you avoid this sort of rapid cycling between two states, which you don't want for that type of system. And it's exactly this level of control that the 555 is giving us when it's wired in this way.
So I hope that, although it's been a bit late in coming, that this supplementary video will help you in diagnosing any issues that you might be having if you're trying to build that circuit, or perhaps even suggesting ways that you can use that mode of wiring for a project. But let me know anyway, one way or another. See you soon.